Let us take a look at this. If alpha and beta are different complex numbers with modulus of beta equals 1, then find the modulus of this expression, right? The modulus of beta minus alpha over 1 minus alpha bar beta. Okay. Now, how do we approach this question? As you can observe, there are two complex numbers involved over here. And when you go about thinking how to approach this question, you would find that your hands are tied, pretty tight for that matter. Okay, how to get free from that tightness? What is the problem in this particular question? Alpha and beta are different complex numbers. Okay, so alpha is not equal to beta and both are complex numbers. Okay, with magnitude, modulus of beta is actually equal to 1. This is given, modulus of beta equals to 1. Okay, both of these are given. Okay, we are supposed to find beta minus alpha over 1 minus alpha bar beta modulus, and this is supposed to be found, right? As you can clearly observe, there's not much information given about alpha in the given question. Only a little bit of information is given about beta, that its magnitude is 1, its modulus is 1, and we are supposed to find this complicated expression somehow. How do we go about approaching this kind of a question, or this particular question in general? Let's talk about this one. So since there's not much information, there would be some manipulation and things would get simplified, right? What can we do with this expression over here? Let's try to use this expression somehow. Okay. So modulus of something actually is very limited knowledge, very limited properties are there of modulus, right? And one of the very important properties of modulus, you may recall, is mod z square is actually equal to z bar. This is one very important property of modulus where we can use z and z bar, right? I'll use this property first. So modulus of beta minus alpha over 1 minus alpha bar beta. Let's try to find the square of this modulus. Okay, I'm trying to find the square of this, and how do we go about finding this? This is mod z square is actually equal to z times z bar. That is, this complex number mod square would be actually equal to this complex number times its conjugate. So what do we have is beta minus alpha over 1 minus alpha bar beta, and we have beta minus alpha over 1 minus alpha bar beta complete conjugate. That's what we have on the RHS. Right. Now that's actually Z1 upon Z2 bar type of a thing. And what happens in this case, this will become, the bar will go on the numerator and the denominator. What you get is Z1 bar over Z2 bar. Using property, the other property, I'm writing the property over here. Z1 over Z2 complete bar is actually equal to Z1 bar over Z2 bar. That's the property that I'll be using next. So what you have over here is beta minus alpha is okay. 1 minus alpha bar beta is also okay. And what you get over here is beta minus alpha complete bar over 1 minus alpha bar beta complete bar. This is what I get. Another property of conjugate. What's that? Z1 plus Z2 bar is actually equal to Z1 bar plus Z2 bar. Yes, this is what we know, right? So let's use that. Next, I'll use that. This is beta minus alpha, which is okay. This is beta bar minus alpha bar in the numerator. What happens in the denominator is, I already have a 1 minus alpha bar beta. And what does this become? This is 1 bar, which is actually equal to 1 only, minus alpha bar bar. Okay, alpha bar beta whole bar would be actually equal to alpha bar bar. That is conjugate of alpha, which is actually alpha only. And beta conjugate would be actually equal to beta bar. This is what I'll be getting. Right. Now, as you may observe, we can simplify these expressions, right? Let's multiply them together. And what do we get? On multiplying beta and beta bar, we get beta bar minus beta alpha bar. That is, let's write it as alpha bar beta, right? I'm multiplying this beta with this beta bar, applying the distributive law. Beta times alpha bar is this, alpha times beta bar minus alpha beta bar. What next? minus alpha and minus alpha bar. What is that equal to? That's equal to plus alpha alpha bar. That's equal to this. Right. What happens in the denominator? In the denominator, you have 1 times 1, which is 1. 1 times alpha beta bar. This is what you have. Minus alpha bar beta in the denominator. And the last term would be minus alpha bar beta minus alpha beta bar. That will be actually equal to plus alpha alpha bar beta beta bar. Now recall, there was one more condition which was given, and that condition was only on beta. Modulus of beta is equal to 1. And since modulus of beta is equal to 1, we know that, I'll use another idea over here. Beta bar is actually equal to modulus of beta whole square, which is equal to 1. And yes, that is something I'll be using next, that beta bar is actually equal to 1. So this becomes 1 minus alpha bar beta minus alpha beta bar plus this is, what is this? Alpha bar is actually, alpha bar would be actually equal to, what do we have? Alpha bar would be actually equal to mod alpha square. So this is mod alpha square over, what do we have over here is, observe this is a 1. Then there's a alpha beta bar, okay, let's write it as over here. There's alpha bar beta, let's write it over here. Okay, those are the two terms. What about the last term? You have a alpha bar, which is mod alpha square. What about beta bar? Beta bar is mod beta square, which is equal to 1, and this is what I get. Since beta bar is equal to mod beta square is equal to 1. That's what we have in the bracket over here. Since this is it. And what do you get over here? Do you observe that this numerator is exactly same as this denominator over here? Yes. If you can observe that, we say that these get cancelled, and what you get is this is equal to 1. So modulus square is equal to 1. What will modulus be equal to? Therefore this modulus is equal to 1 and minus 1. No. Modulus is positive, right? So it is equal to plus 1, and yes, that is my answer for this question over here. That's the analysis behind that, and that's the important step behind all of these things, because this modulus is pretty difficult to find, but with this idea, the very important property of modulus, the most important property of modulus, is modulus of z square is equal to z bar, and on the basis of this, you have solved this question, right? That is all. Yes, that is all in this question.